Following on from the previous video, we were trying to look at an alternative way of integrating the arctan of y, and we got to this stage here where we still needed to work out the integral of tan of y now. So it was here, and then we used integration by parts to get to here. But then we still needed to work out this. So now our next question is, how do you work out the integral of tan of y with respect to y? Okay, so now we need to settle this now. So let's try and integrate tan of y dy. So visualize tan of y as this. Tan of y is sine of y over cos of y. So rewrite this as this thing here. So rewrite this thing here as this. And when you're integrating, always keep an eye out on something being the exact derivative of another thing. So if you notice this here, this is the exact derivative of this. So we can immediately jump to natural log of the absolute value of cos of y. Well, integrate this, it will then give you this. Okay, so this bit here, we still need to work out the integral of tan of y dy. Well, if you integrate this, it will give you this. It will give you this. So this whole thing here, will then become this. Will then become this. Okay. And then in the previous video we said let y be the arctan of x. So now we can just put this back into here and into here. So if you look at this here, if you just look at this bit here, you're tanning the y. So if you tan the y, if you tan the y, it would be this inverse tan of x. So this whole thing here will just be x. So this bit here will be x. So this bit here will be x here. And then the y itself is this. Okay, and then now you've got to put this into here. So you've got cos of inverse tan of x here. Well, if you put this into here, this whole thing here will become this. Okay, so this bit here will then become this. So now we could leave it as this, but it looks really ugly. So let's tidy this bit up. Okay, so now tidying this bit up, looking at this, create a scenario in such a way that this statement is true. So create a scenario. So looking at this here, create a scenario where this statement is true. So if you look at this, tan would be the opposite over the adjacent. So this here is your tan. So if you look at this here, so arctan of x would actually mean this bit here actually means the angle itself. So arctan of x is actually the angle. This bit here is this angle here. Okay, so when you cos the angle, it would be this. So when you cos the angle, it would be this. So now what is this? What is the hypotenuse? The hypotenuse would be root x squared plus 1. Okay, so let's start again. To translate this, you would look at this and create a triangle in such a way that this statement is true. Well, tan would be this. So to create this as x, and then this here, it could be anything. Let's choose 1 because it's nice and simple. So arctan of x actually represents the angle. Arctan of x actually represents the angle. So now when you look at cos of the angle, well, cos of the angle would be this. So it would be 1 over the hypotenuse. The hypotenuse is this. So this, if you tidy this bit up, it would then become it will then become this. Okay. Let me think. Yeah, and then you would get rid of the absolute value here, because this statement here, this thing here, will always be above 0. So so you can forget about the absolute sign here. So this whole thing here will then become this. Okay. So now now our first method gave us this. So our first method of working out the arctan of x gave us this. The second method gave us this. The thing is, these two are exactly the same, but just written differently. Okay, and so let's double check our second method. So double check our second method. Let's differentiate it. So so this is our second method here. So let's try and differentiate this. So differentiating this. So here we've got to use a product rule. So product rule is differentiate this, leave this the same. That will then give us this, and then leave this the same, differentiate this. That will then give us this. Okay, so leave this the same and differentiate this. That will then give you this. So now now we've got to differentiate this. So visualize this whole. Hang on. Visualize this whole thing here as natural log of. Let's visualize it as x squared plus 1 to the power of minus a half. So visualize this whole thing here as this thing here. Okay, so when you differentiate this, it will be 1 over this thing here, which would be this, and then you've got to times with the derivative of the bubble itself. So that will then give you this. But then you've got to times with the derivative of what's in here, which will be 2x. So, well, differentiating this whole thing here will then give you this thing here. So now tidy this up. So so this thing here actually becomes this, because you've got, well, think about it. This thing here will then become this, and then this thing here. Visualize this thing here as to the power of positive. Well, visualize this thing here as this thing here, and then you've got the 2 here, which cancels out with this, and then you've got a negative here. That will then give you this. Well, tie this thing up, it will then give you this, and then this thing here gets multiplied to the top. This gets multiplied to the top. So this x here is this x here. This here will then be this. Now visualize this thing here as this thing. Well, square root. Don't forget this here is a square root. Square root time. Well, visualize this thing here as this thing here. So now these two will cancel out, because this in effect is a square root. So cancel it out, giving you, well, to the power of 1 is just that, giving you this. So this whole thing here will then give you this. And notice that these two are the same. So they cancel each other out, leaving you with arctan of x. So that's our answer. Okay?